All right, this is section 3.6. We're talking about absolute value functions. And actually, this is going to be a combination of what we just learned with transformations and what we learned way back in 2.6 with absolute value functions and how to solve the equations. Okay, so what absolute value is, it's a function is commonly thought as providing the distance from 0 to a number on a number line. So algebraically, for whatever the input is, the output is the value without regard to the sign. So the absolute value of anything is going to be a positive number. So the absolute value of -4, well, that's a positive 4. Absolute value of 4, well, that's going to be 4. Okay, so graphing absolute value functions, we learned this back when we were looking at transformations. This is the basic function right here, y equals absolute value of x. Now it looks like it's a V shape and it starts at 0 and then it goes upward. Okay. So when you look at do the graphs of the absolute value functions always intersect the vertical axis, the horizontal axis? Well, for the vertical axis, so here's our vertical axis. Yes, it will every single time intersect or cross over the vertical axis. But it doesn't always have to intersect the horizontal axis, okay? Horizontal axis right here. In this case, and by the way, for the horizontal or the vertical axis, it intersected right here, right here, right here, okay? But it doesn't always have to intersect the horizontal axis. Notice here, the graph has not crossed over the x-axis. Here, it hadn't really crossed over, but it barely touched it. So since it touched it, we can say it intersected. And here, it intersected the x-axis or the horizontal axis here and here. Okay, so yes, it'll always cross over the vertical axis, but no, it won't always cross over the vertical axis. Just depends on the graph. So let's look at this one. Given the graph below, we're going to write an equation for it. So notice we know that it starts at 0 and it goes upward. This one looks like it's been flipped over, so we know that it's going to have a negative in front of the absolute value. And then notice it has gone to the right 2 units. Okay, so that's going to be x minus 2. And then it scooted down 1 unit, so minus 1. And this would be our equation for this graph right here. Okay, if we look at this one, okay, it's going upward in a V shape. We know that the original starts at 0 right here. Looks like it has moved over 1, 2, 3 to the left. Okay, so this is going to be x plus 3 since it went to the left. And then it moved up 1, 2, 3, 4, so plus 4 units up. So that would be the equation for this graph. Okay, now we're going to graph y equals 2x minus 4 plus 3. So I'm going to create a t-table. Now the only reason I'm doing that is because of this 2 right here. Now if we didn't have that 2 right there, if we just had x minus 4 plus 3, what we could do, so let's mark that out. That was just x minus 4 plus 3. What we could do is, okay, we know the original starts here, and then we would move to the right 4 units, and then up 3. Okay, move to the right 4 units, up 3. So we would have this right here. Okay, but since I've got that 2 right in front of it, I'm going to create a t-table. And I'm going to use, let's see, we'll use -1, 0, 1, 2, 3, 4. Okay, so I plug in -1 into this equation right here. So we'll have absolute value of -2 minus 4 plus 3. because a negative 1 times 2 is negative 2. That would be a negative 6 plus 3, so that would be 6 plus 3, so that would be 9. Okay, so then we would have 0 times 2, which would be 0. So that would be the absolute value of 4, which is 4. So that would be 7. Okay, and then 1 times 2 is 2. So 2 minus 4, that would be negative 2 plus 3. So that would be 2 plus 3. So that would be 5. Okay, and then 2. 2 times 2 is 4. 4 minus 4 is 0. So that would just be 3. Okay, 3 times 2 would be 6. So that would be absolute value of 2 plus 3. So that would be 2 plus 3. So 5. And then 4 times 2. So that would be 8. 8 minus 4 is 4 plus 3. So that would be 7. Okay, so if we plot that should be pretty close to what we already had. So negative 1, 9. So that goes off the chart just a little bit, so that'd be about there. 0, 7 here. 1, 5 here. And then 2, 3 here. 3, 5. And then 4, 7. Okay, and then I just connect my lines. And then there's the graph of y equals absolute value of 2x minus 4 plus 3. Now let's move on to solving absolute value equations. Okay, so the absolute value of x is written as the absolute value of x, so they have the bars around it. It has the following properties. If x is greater than or equal to 0, then absolute value of x is x. If x is less than 0, then absolute value of x is negative x. What that is saying is for the real numbers a and b, an equation of the form the absolute value of a equals b, with b being a positive number or 0, will have solutions when a equals b or a equals negative b. If b is a negative number, the equation absolute value of a equals b doesn't have any solutions. And that's because the absolute value of anything is always positive. So if you have the absolute value of a equal to b, and we're saying that absolute value of anything is always positive, we're saying b is negative, well, positive can never equal a negative. And if they can never be equal to each other, then you have no solution. Now, if you have an absolute value equation in the form ax plus b equals c, then you can have 3 of these potential solutions. If c is a negative number, you have no solution because of the explanation I gave you right here. If c is equal to 0, then you have one solution. And if c is greater than 0, if it's a positive number, you're going to have 2 solutions. So what you want to do is you want to isolate the absolute value expression on one side and put everything else on the other side. And if c is a positive, then what you're going to have is, we said 2 solutions. It will be ax plus b is equal to c, and ax plus b is equal to negative c. So let's look at this one right here. The first thing that we need to do is get the absolute value all by itself on one side of the equation. So I'm going to move the 8 over. So absolute value of 1 minus 4x is equal to 13 minus 8. Okay, so we've got the absolute value of 1 minus 4x is equal to 5. And then what we're going to do is 1 minus 4x equals 5, or 1 minus 4x equals negative 5, and then solve both of those equations. So I'm going to subtract 1 from both sides. And I'll just go ahead and go across here. So I have negative 4x is equal to 4. Negative 4x is equal to negative 6. Divide both sides by negative 4. Okay, so here I have, I'll write it right here, x is equal to negative 1. Here, I'll write down here first, 6 over 4, but I can take a 2 out of both of those. So that would be x is equal to 3 over 2. And notice I had a negative over negative. That would give me a positive. So my two solutions are, and you would want to go back and check these just to make sure, is x equals negative 1 and x equals 3 over 2. Now notice when we got the absolute value all by itself with a number, this number was a positive number. So that means that we should have had two solutions, and we did. So let's look at this one. Okay, the absolute value is already on one side. So I'm going to go ahead and do 4x plus 3 is equal to 3 minus x, or 4x plus 3 is equal to the negative version of the entire thing. So be careful with that. So I'm going to add x over here. So that's going to be 5x plus 3 equals 3. Subtract 3 from both sides, so 5x equals 0. Divide both sides by 5. 0 divided by anything is still just 0. Okay, I'm going to distribute this negative to the 3 and to the x. That's going to make it positive. And I'm going to subtract x from both sides, so I'm going to get 3x plus 3 equals negative 3. Subtract 3 from both sides, so 3x equals negative 6. Divide both sides by 3, so x, and let me write it over here, x equals negative 2. Okay, so those would be my two answers right there. And you always want to go back and check them just to make sure, but these two do work out. Okay, so same thing, we're going to move over that negative 2 and that 6 to get this one all by itself. So 6 times 10x minus 3 minus 2 equals negative 2. First thing is to add the 2, don't divide first. Add the 2. So 6 times 10x minus 3 equals 0. Divide the 6. So absolute value of 10x minus 3 is equal to 0. Okay, so now notice I've got this right here. This equal to 0, so I should have one solution. So meaning I don't have to do a positive and a negative 0 because 0 is neutral. It doesn't have a positive or negative. So what I would have is this right here. 10x minus 3 equals 0. Add the 3 to both sides. 10x is equal to 3. Divide by 10. So x is equal to 3 over 10. And that would be my final answer for that one. All right, so let's take a look at this one, and we are going to move over the 18 and that 6. Okay, so move over the 18 first. So that's going to be negative 18. Then divide both sides by 6. So this is going to be the absolute value of 5x plus 9 is equal to negative 3. Now stop right here. What we have is a positive number here because of the absolute value, and what we have here is a negative. Can a positive ever be equal to a negative? Can positive 4 equal negative 4? Never. That can never be equal to each other. Okay, so positive can never equal to a negative, so you can stop right there and say that this is no solutions. Or you can say no solution. That sounds better. Okay, so Let's go to this last one.